Hi and welcome to this GCSE chemistry tutorial. My name is Isuru and today we'll be learning about moles, masses, and relative formula masses. And so this is quite a daunting topic. I know from personal experience, and I know other students have struggled with this as well. And it's a little bit tricky to get your head around, but I hope by the end of this session, I can convince you that this is, in fact, kind of a not simple, but it is not as hard as it seems. So the aims for this session will mainly be to be able to use this knowledge practically, and to be able, at the end of the session, to be able to calculate how many moles of atoms or molecules there are in certain substance of known mass. And then we hope to be able to calculate the mass of an ion in a molecule with known amount of moles. Now, what does all this mean? Well, before we go into that, just please let me know if you have any questions throughout, or if you want me to go a little bit faster, or if you want me to go a little bit slower. This is highly interactive, and I hope you can participate. And these are just some extra bits that I've added since this is our first session, but bearing in mind this is a demo tutorial, I won't really go into this too much, but normally I would just do this a little bit for 5 minutes just to see what your motivations are, what drives you, why you want to do well in chemistry, and sort of gauge what you think of, if you think it's interesting. And yeah, but anyways, let's get straight into it. So where do we even begin to explain this? I think this is part of the problem, because there are a few concepts here and they are a little bit difficult to explain without explaining the other. But we'll try our best here. And so first of all, let's talk about the Avogadros number. So for now, just know that it's a number, okay? Just know that it's a number. It does have a little bit of a meaning, I promise, but for now, just remember that it's this number right here. It's 6.02 times 10 to the power 23. Okay, so now let's talk about mass and AR. So what's AR? It is the relative atomic mass. So in chemistry, we tend to use grams. We tend to use grams when we calculate the mass of something, also known as the weight of something. And the relative atomic mass is essentially the average weight of each atom of the periodic table, or each element, if you will. So for example, for helium, you can see here the atomic mass is the number in the top corner here, top right corner, it's 4, it's around 4. So each of these atoms, they have a number in the top right corner, and this indicates its relative atomic mass. Now, how is this relevant, and how is this linked to the Avogadros number? I'm about to tell you why right now. Okay, so the relative atomic mass is important. Why? Because it is essentially a method that we use to compare each atom and element to each other, to see which one is heavier, given that the number of particles, the number of atoms are the same. And so we have determined that we use Avogadros number for that. So which essentially means for every single atom of the periodic table, for every single substance in chemistry that is given in the quantity of Avogadros number, it has an assigned mass to it, which is called the relative. For atoms, it's called the relative atomic mass. And this is the number that you see in the top right corner. For molecules, this is called the relative formula mass. So that means, what that means is essentially 6.02 is the Avogadros number of an atom. So for example, of beryllium, just to take a random atom. Sorry about that. Will be about 9 grams. 9 grams. Okay, and the same for lithium. 6.02 times 10 to the power 23 atoms of lithium will be around 6.9 grams, or you can round that up to 7. So now for the relative formula mass, as I mentioned, this is what we use for molecules. So for example, for H2O, we have CO2, HCl. It doesn't really make sense to just talk about the relative atomic mass because these aren't atoms, these are molecules. These are comprised of atoms though. But the concept is essentially the same. So we got 6.02 times 10 to the power 23, the Avogadros number of, for example, water, of this substance right here, which means that we will have a relative formula mass that is comprised of its atoms, the mass of its atoms. So we can find that very easily by calculating with the 2, it's got 2 hydrogen ions. So let me just write that. I'll just erase these because now we're just looking at water. So it's got 2 hydrogen ions. That means 1 gram for each. So 1 times 2 plus the oxygen. So let's see how much oxygen, what's the relative atomic mass for oxygen? It's about 16. It's about 16. So 16 grams. And by the way, there is a little bit of maths involved in chemistry. And so do let me know if you need any help with that. I'd be very, very happy to help with that as well. But just assuming that you know how to calculate this. So 1 times 2 is 2 plus 16 is 18. So the relative formula mass of H2O will be 18 grams. Right. So now we're going to talk about the mole. We're going to talk about the mole. And this is a very daunting topic, but I promise it's simple. Because in English, we have something called a dozen. 1 dozen. We use it to count eggs. Essentially, when we bake a cake, when we cook food, we use a dozen. Hopefully, you won't use a dozen of eggs in one portion, but this essentially means 12 eggs, or 12 of the quantity. Same way, 1 mole equals Avogadros number. So I realize we're running a little bit short on time, but what I would say is 1 mole equals Avogadros number. And what that means is that 1 mole will give, because we know that Avogadros number will give the relative formula mass of a molecule such as H2O, and Avogadros number will give the relative atomic mass of an atom. 1 mole of, for example, H2O we know that the mass will be 18 grams. 1 mole of, say, beryllium we know that the weight will be 9 grams. Okay, so now let's solidify this. So because we're running out short of time, I'll just show you what I would do, how the sessions would run at this point in time. We just solidify this concept a little bit more, and here I would just talk through the formula and talk through these questions and make it as interactive as possible before the student can then try themselves out, test themselves out on real questions, on more difficult questions. And it's up to them. I'll leave it up to them. If they want to do it with extra help, I'm happy to help them. If they just want to do it alone and then for me to be silent, then I'm happy to do that as well. It's mainly for two reasons. One, to really help this to see what the progress is on this topic and see if we need some more time in the next session. Or number two, to see if there is how their confidence is relating to this topic, because I really want to push their confidence up during these sessions. And then finally, I will include this last page, basically where we plan the next session. We form a more personalized plan. We go through the aims again, make sure they have achieved those, and we talk about some homework. And the homework will always be, through a dialogue between us, and we'll agree on something to do, and then I'll hold them accountable. I'll hold the student accountable for that. So thank you very much for watching, and hope to hear from you soon.